In this segment, we're going to be examining the rules for dealing with products of functions and quotients of functions and the derivatives of those products and quotients. And we're going to find that although these processes are relatively easy, the algebra within them gets to be a little bit cumbersome. That is, we're going to be dealing with more terms and so forth than we are comfortable dealing with. Maybe we're kind of shifting back to when we were talking about limits of difference quotients, where we had to lay out a lot of stuff like this. So just give yourself a lot of room and understand the overall idea, the basic concept involved, and you're not going to have a lot of trouble. The first item is the product rule, and it works like this: that the derivative of a product of functions is the sum of two products, actually. It is f times the derivative of g plus g times the derivative of f. And even more generally, we can stretch it out a little bit and get a general idea of how this is flowing by looking at the derivative of f times g times h. And it is the sum of three products. And here's one of those products, and here's another product, and here's another product. Now, notice that all we're doing in each of these items that are being added is that we're taking the derivative of one of the functions and multiplying times the other two functions. So here we have f times g times the derivative of h, and here f times h times the derivative of g, and here g times h times the derivative of f. You see, and that generally is the way that these will flow. So if we have that idea, then if we know that concept, then the way that we proceed through is to write down the original function, identify that we need to use the product rule, and then apply the product rule sort of symbolically, like this. If we have f of x is 2x cubed times 3x minus 5, we're thinking of this as a function and that as a function. All right, so we're going to apply the product rule. And it is that we're taking this factor or this term and multiplying times the derivative of the binomial. And then we take the binomial and go with the derivative of that outside term. So we write that down. We have to write 2x cubed times the derivative of the binomial, and then the binomial times the derivative of the 2x cubed. And now let's resolve this. What does this mean? Well, let's see. The derivative of 3x minus 5 is simply 3. And we just pop that in. And then over here, bring down the 3x minus 5, and the derivative of 2x cubed is 3 times 2, 6x squared. And now go ahead and expand. 3 times 2x cubed is 6x cubed. 3x minus 5 times 6x squared. 6x squared times 3x is 18x cubed. 6x squared times minus 5 is minus 30x squared. Collecting the like terms, we get this. So here's our derivative function. And the best advice that I can give you here, the calculus of this is not hard. The algebra of it is what makes it tricky. And so you have to pay very careful attention to what you're writing down and flow through from step to step. And this is going to become increasingly true as we go along. The calculus will not be so challenging. The algebra within the calculus is the more challenging part. Okay, let's understand now that I chose this just to illustrate the product rule. There is another way to proceed in this problem. You may have already seen it. Gee, why is this fool taking so much time when we could have done it another way? Well, I'll show you the other way. The other way is to go ahead and multiply here from the beginning. So just change f of x into, let's see, 2x cubed times 3x. That's 6x to the fourth. And then 2x cubed times minus 5 is minus 10x cubed. And now the derivative is 24x cubed minus 30x squared, as we had before. Remember that if f of x is 5x to the fourth power, then by the constant multiple rule and the power rule, we say that 4 times 5 is 20x to the third power. All right, that's the fast and easy way to do it. Suppose you looked at this and in a moment of not remembering that other business, you said, let's use the product rule. Well, let's use the product rule. We have this item, our function, times that function. Well, that's a constant function, and that one's okay. That's kind of familiar to us. But using the product rule here, we would have the derivative would be 5 times the derivative of x to the fourth, and then plus x to the fourth times the derivative of 5. So let's see, 5 times the derivative of x to the fourth, this would be 4x cubed. And the derivative of that constant 5 turns out to be 0, so that term goes out. And 5 times 4x cubed is 20x cubed, as we expected from before. So it all kind of works out and blends in, and this is what we would expect to have happen here. We want that consistency to occur in mathematics. Here's the format for finding the derivative of a quotient. Now, it's written in very general terms involving the quotient of two functions, but really the way we're going to use it is we're going to be talking about the derivative of a quotient, and we're going to have a numerator and denominator. So just think of this as numerator and denominator, and notice that it is that the denominator function or the denominator expression or whatever's in the denominator is going to play a significant role over here. It appears in several places. So we have the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. So if we have this as our function with a numerator and denominator, then the derivative of our function is found by, well, think of it, go through this process a couple of times and think of, let's see, numerator over denominator. F is the numerator, G the denominator. All right, so we have denominator times derivative of numerator minus numerator times derivative of denominator over denominator squared. So, following the same format, and the first few times you do this, use this as kind of a template and just fill in the information into the proper spot. And go ahead and use that template time and again. And then through multiple use of this and in practicing it, it will enter your mind as a memory. And you don't have to actively memorize it, it will just come to you. And let it come to you in that way. Just write this on the side of your paper or somewhere to refer to, and after you refer to it a few times, it will be sort of automatic. Okay, so let's see. Referring to this, we have, let's see, denominator times derivative of numerator. So we have denominator times derivative of numerator, then minus the numerator times the derivative of the denominator, and then all of this is over the denominator squared. And then off we go with performing indicated operations. It's this part that's the most important part. The rest of it is manipulation. And of course finding the derivatives of these little rascals. But we have, let's see, the derivative of 2x cubed is 6x squared. And over here the derivative of x minus 5 is simply 1. So from here we expand in the numerator and collect as we're able to and so on. And I'm confident that we can do that from here. The idea is to use this as a format or a template and plug in the proper information. Now, once you have the quotient rule at your disposal, once you have it available to you, well, first of all, you figure out after you use it a couple of times, because it's so convoluted, that it's not your least favorite way of finding the derivative of a function. You'd like not to use it if you can because it has so much manipulation involved in it. So you look for an outlet. You look for a way to manipulate the original function so that you don't have to use the quotient rule. And that's okay. It's all right to do that unless you're trying to practice the quotient rule directly. But a lot of times you're going to find out that functions can be manipulated so that you can get around using the quotient rule. Let me show you a couple of those techniques. Here, for example, and we've seen this before, we could use the quotient rule here. We could apply the quotient rule, but we have seen before that if we kick the x to the fourth upstairs, making it x to the negative fourth, and think of 3 over 2 as the distinct coefficient here, we can rock along and find the derivative very quickly. So we would have y prime then as, let's see, I'm going to take kind of a long approach to it because I'm dealing with fractions and negatives. I just don't want to think about it. So I'm going to think of 3/2 times the derivative of this. That's negative 4 x to the negative 5. And now the negative 4 here gives me, let's see, the 2 and the 4 cancel. I have negative 6x to the negative 5, or negative 6 over x to the 5th. And in this one, The 2x cubed minus 5 is the numerator. We have a constant for the denominator. But when there's a single term here, a lot of times, as we saw over here, we can kick things around, we can move things about. And even with a constant denominator and a binomial numerator, we can think of 6 as being 1/6 times that numerator. You see, and in this way we are avoiding using the quotient rule once again. I hate to say that we're doing a manipulation just to avoid using one of the rules, but that truly is probably what's going on. We're trying to efficiently get to our derivative. Sometimes we have to use the quotient rule, but we don't always have to. We can manipulate our way out of it. And here, let's see, so the y prime then is 1/6 times the derivative of this. The derivative of 2x cubed is 6x squared. The derivative of the 5 is 0, so it goes out. 1/6 times this gives us x squared. Here's another one. We have 4x to the 3/2 in the numerator, x in the denominator. Looks like we need to use the quotient rule, but no, we can get ourselves out of it. This x can slip up to the numerator and becomes x to the negative 1. Multiplying here, we're simply adding the exponents. 3/2 minus 2/2 is 1/2. So 4x to the 1/2. Take the derivative and we have 4 times the derivative of this. And notice that I'm kind of taking the long road here. I could say 1/2 of 4 is 2 times x to the 1/2 minus 1 is negative 1/2. You see, and do all of that in one step. Or I can say, well, I'm going to relax. I'm not going to try to think too far ahead, and that's a good idea. Bring down the 4 and talk about or think about the derivative of this. So it's 1/2 x times an exponent, which is 1/2 minus 1. Okay, good. Now evaluate or simplify. Half of 4 is 2. 1/2 minus 1 is negative 1/2, so the derivative is 2 over the square root of x.